pleasure to host our first seminar dedicated to the zooarchaeology, stable isotope, and biomolecular approaches of the Caucasus and Levant. So the last decade has seen an influx of new techniques such as stable isotope analysis, biomolecular approaches, but also novel techniques in zooarchaeology, in archaeology in general. But today, through the presentations of our speakers, we will see how these techniques can be applied to old as well as new questions of the archaeology of the Caucasus. So we warmly welcome our 4 speakers and all participants. And we have pasted a link in the chat box that links you to a shared document of today's presentation, in which you can follow along with today's program, presentation abstracts, and speaker biographies if you wish to do so. I will now quickly pass over to Magda, who's going to introduce our network for those of you who are joining us for the first time and don't know about our network.
Thank you, Gwen. I will now take a moment to introduce you our network to those who are joining us for the first time. We are the group of master and PhD students working in the Caucasus. The aim of our network is to bring regional archaeologists, anthropologists, historians, and to discuss ongoing research in Caucasus and nearby and adjacent regions. The network is inclusive and encouraging environment. We're providing a space for the young scholar to showcase their work and introduce their facilitating knowledge and exchange among the scholars and early career researchers. So now I'm going to give the stage to Gwen. Please, Gwen, to introduce the program.
Yeah, so the event is structured in the following way. So after each talk, we'll have a short Q&A of around 5 minutes where you can ask questions. So if you have questions for a specific talk, please write them in the chat box, either during the talk or after the talk, and we will collect them and raise them during the Q&A. And if you don't have enough time during the discussion, or you can also use the raise hand button on the right-hand side at the bottom, and you can unmute yourself and ask your question directly if you wish so. Okay, so I will quickly introduce the program. So unfortunately, our first speaker, Maria, cannot make it due to unforeseen circumstances. So we will directly start with our second speaker, which is Adeline Vautrin. She will talk about Caprine breeding strategies of the first herders in the South Caucasus, the example of Kültepe in Nakhchivan, Azerbaijan. Then we will hear from Dr. Rémi Berthon on the resolution of isotopic proxies to investigate herd mobilities in the Caucasian environments, modern references and application to Ovçluar Tepesi of the Chalcolithic, also Nakhchivan, Azerbaijan. Then I will present myself on investigating Kura-Araxes pastoral practices in the Caucasus and the Levant using zooarchaeology, stable isotope analysis, and zooms. And finally, we'll hear from Dr. Siavash Samei talking about backbones of society, tracing animal use in subsistence and manufacturing economies of the early Bronze Age settlement of Köhne in northwestern Iran, which will be followed by a discussion at the end where again you can ask some more general questions or specific questions you have for a talk. So just some basic housekeeping rules. Please mute yourself, especially during presentations. And as I said, please put your questions in the chat box or ask them directly in the question round. Please also note that the event is recorded and it will be made available on our YouTube channel afterwards. And it will be used on various social media channels. So we'll go along and introduce our first speaker, which is Adeline Vautrin. She's a PhD student in archaeology at the Natural History Museum in Paris in France. She's interested in animal husbandry practices of agro-pastoral societies in the South Caucasus from the Neolithic to the early Bronze Age. She uses classical archaeological approaches, but also chronological and isotopic approaches to understand past zootechnical practices. The floor is yours, Adeline.
Adeline, you're muted.
Can you see in full screen my what I share?
Yeah, we can see it and we can hear you now. Yeah.
Perfect. So first, I want to thank you, Gwendoline, for organizing the session on Zooarchaeology and to inviting me to present my work on the Neolithic in Nakhchivan. So I will present you some data of my master thesis done some years ago on Caprine building strategies of the first elders in the South Caucasus, illustrated by some tips from Kültepe I in Nakhchivan. So Kültepe is located in a high plateau at more than 800 meters above sea level. And in this region, there is a lot of mountains, and some of them can reach at least 300 meters height. It is also a very continental climate with dry summer and cold winter. And at higher altitude, the mountain pastures are less arid in summer, which are favorable to seasonal settlement by shepherds, as you can see here. Pastoralism is essential part of the cultural and economic life in the region today, and different forms of pastoral practices can be documented as vertical mobility, that we can know as transient, or horizontal mobilities, which can reflect mobilities without altitudinal gradients. Recent genetic studies have shed light on the history of the Caucasian population during the Neolithic period, and suggest that there is a gene flow between farming population from Anatolia and Mesopotamia, and with hunter-gatherer population of Caucasus and Iran. There is also no domestication in this region. So there's some question that can be questioned as what were the breeding practices of the first breeders? What was the technical knowledge? And also what kind of mobility was in the firstly in the region? So to address the questions, I investigate bones and tips from Neolithic site of Kültepe, where there is two levels from the 7th and 6th millennium BCE, and where animal husbandry like sheep and goats represent more than 80% for the level 1 and more than 80% for the level 2. So firstly, I will investigate the reason for animal husbandry by seeing the kill-off pattern. So for this, we will examine the age at the age at which the animal dies. It can be estimated with the various measurements in the text, also with some schema of eruption of the text, and also with the usual. Then we can construct with scale of graph and giving a class to animals to A for the youngest one, to HI to the youngest. So for the level one, we can see that for sheep, there is here C and D that are the most important, and it means exploitation for meat. But if you look at the goats, it's different. They live longer, they are kept alive longer, and you can see it with EF and G. And it means that they were probably exploited for meat, because there is some important here, but also for milk. but we don't have a lot of mandibles for this context, and it is not very good for the statistic. But for level 2, it's better. And what you can see with sheep, it's always still with C and D, so for meat. But with caprines, it's different. We have a mix for capra, for goat, it's different because we have a mixed exploitation with meat and milk. We do not exclude exploitation of fleece, but because class HI for the older animals are not represented, we don't think that there is something focused on fleece. Then, yes, and also, as you see it, young animals who just are born, like in class A or B, are represented. So we think that the animals were probably on the site at the season at the birth of the animal. But for this, we have to know it because breeders can control it. So that's why I will now present the isotopic approach of my work with the isotopic analysis. So I did it on 14 molars from sheep, goat, and also gazelle. And it represents more than 200 samples that I measure for carbon and oxygen, and more than 100 samples for strontium analysis. We did it at the Muséum naturelle at the University of Montpellier, and also for the zooms and the identification and confirmation of the identification. I want to thank Louise Lemillot for the identification of the gazelle, that is Gazella subiturosa, and Fabrice Bray for the confirmation of sheep and goat in our assemblage. So just the principles. So during the processes of enamelization of the teeth, everything that the animal eats or drink is recorded. So by sampling, by the sequential sampling of the perpendicular way of the cognitive, we can have this kind of representation with here the point with here, and the last one next to the root. And we have a requirement for around 1 year of recording. So with oxygen, we can have information about seasonality because the values will change with the temperature. So when values are low, it's winter, and when it's high, it's summer. And with this, we can also have an idea of the season of birth of animals, because when animals are all born in the same season, the requirement will be in the same time. So summer will happen in the same time, winter again. But like here in the yellow, you see that there's animals who have a maximum completely different. But because of the height of the teeth, we have to modelize it. And with modern reference of season of birth, we can then know when animals were born in the archaeological time. So I do it on, I was able to modelize only 6 animals of my sampling, and I did it on M2 and M3. And what we can see is that there is first winter season of birth, that is classical, and this is what we found in wild animals. But we also have some animals who are born in summer or last summer, the beginning of autumn. But some of them are goats, and we don't have a birth reference for goats, but we expected that the time of linearization is the same, and we can trust this data as other colleagues do in publication. So there is probably for goats an availability of the milk in winter, and maybe it's something that's why goats were exploited more for milk. it was well together. But we cannot say if there is 2 seasons of birth in winter and in autumn, or if there is a continuum of birth during all the spring and summer, because we are missing a lot of data, and it will be good to continue in this way in the future. Then for the diet and the mobility, I will focus on 2 elements: carbon that reflects the diet, and the values reflect the metabolism of 2 kinds of plants: seafood plants that we found in plains and high altitudes, and seafood power plants that we found in dry environment and saline environment, and mainly only in the plain. In some terms, it's a marker of mobility, as the value depends on the geographical traits on which the consumed plants have grown. And this make it possible to determine the animal if an animal is mobile or not, and the frequency of the mobility. So here I will present the amplitude of the carbon, the minimum and maximum. And we can see here that there is one animal that is different as it goes in a C4 plant area, because it's not in the seafood pure diet. So there is at least one animal with different than the other from a mobility point of view. And also we selected the gazelle to have a reference for lowland area, but as you see it, she is very close to the canopy effect with links to forest. So maybe this gazelle was somewhere next to a forest, and she's not very good to compare for plains values. But if you look at the maximum, it goes well with the others. So she wasn't the best animal to compare with the lowland, but she wasn't almost the worst because of the values. So then when we look at the modern reference for mobility, what we can see here, it's a non-tourism ship from Azerbaijan. And there is here in carbon a maximum who occurs in summer, and it's a good co-variation of carbon and oxygen, but it's very that represents a non-transient animal. But in the case of the transient animals, this maximum appears here in winter. And it's something that we can also find in wild sheep here in Paleolithic time, but it was also the same with maximum in the winter. So I look at which animals have higher values in winter than in summer, and 3 animals are on this kind of pattern. First one, but it's too close and probably not transient, but this one is a very good one. So if we look at closely at the isotopic data, we can see that there is a covariation, no covariation of carbon and oxygen, as you can see it. It's crossed with oxygen and carbon. And thanks to some data, we can see that it goes in 2 areas, one here and one here. And this is what we can find in this this transient ship. Here, one area here, one here. So this one was probably transient. There is also some other animals who have 2 zones of occupation, here and here, but if you look at the carbon, it's a good covariation of oxygen and carbon. So this one was maybe non-transient, as this wasn't got from Azerbaijan. But there is also some other kind of mobility with animals who stay 1 year in one place, and the other years it goes in some different places. And with a carbon with very stable. We also have animals with a lot of mobilities with symptoms and with a high amplitude of carbon. We also have some animals with stable carbon and stable symptoms. But maybe some of these animals represent the data of Kültepe, as we can't have a modern reference for Kültepe because there's a lot of alluvium and colluvium in the site, and maybe various sediment deposits. We are not sure that the modern values of Kültepe is the same as in the past. So we're maybe thinking that Cap 2 here represents the value of Kültepe, as we have the end of his life, because this god died just before the end of the mineralization. So the last points are here, but I cannot sample them. So maybe this area here is Kültepe, but it's completely different from this area of the overlay. So assuming that all individuals lived one month, some months, or all of this life in Kültepe, we wanted to see what happened in all the individuals. So I plot all the carbon and symptom data and to see if there is some location. So here at the maximum one with the goats to Cap 5 with the highest, but it's a large occupation, but one individual seems to be excluded of the area. So maybe it wasn't in Kültepe during all of his life, but I wanted to go shorter with maybe another zone of Kültepe with Cap 2 and Cap 8. But it excluded a lot of animals, Cap 5, Cap 7, Cap 9, and Cap 4. So maybe it was not the place for Kültepe. And this hypothesis is not the best. And a third hypothesis is to just focus on Cap 8 and Cap 5, but it excluded two animals who are biannual in the mobility. So maybe there's an average here, and it's not far from the Earth area, so it could work. But Cap 1 is still not in the zone. But this is not very objective, so we tested the probable Kültepe zone with a 4-group mixture analysis that proposed a main zone at just under 72, just under here, and with a 2 sigma range, we have this area that excluded only Cap 2. So maybe Cap 2 lived in another place, or if you remember, just in this slide here. Oops. This animal died probably on the site, but it's the one who is excluded. So maybe in last time of life, he spent his life in Kültepe, but I don't have it on the requirement. So for the moment, we don't really know which animal, which is a good period, which is a good zone for Kültepe, but we in almost all of the time exclude Cap 1 and Cap 2 are from the same level, so there's no common zone between the two here, and some of them probably don't live in Kültepe during all of the 2 years of recordment, and they're probably coming from other area, and there's maybe exchange with other population, we don't know. And what I presented here was only focused on strontium, but there's also carbon, but I didn't speak. But here you can see that there's very low values compared to all of the other ones. And maybe this area proposed by this Q sigma and the mean here is a good one to know the zone of Kültepe. So to conclude, we have exploitation of sheep and goat for meat, with probably secondary product for goat. We have at least two season of birth, but we don't know if it's a continuum because we don't have enough individuals. And there is maybe goat milk availability in winter. Also, we don't have mobility pattern identified as none of this Caprine did the same thing. So maybe breeders may have kept up investing and trying new territories. And most importantly, it should be remembered that do not represent one herd, but only 10 animals over 1,000 years of Neolithic. Thank you for your attention.
Thank you for your presentation, Adeline. Was really nice. I really liked your slides. Are there any questions in the audience? Okay, I have a question or wait. Okay, there's one question from Tim. Tim, you can also speak freely if you want to, or I can read out your question, whichever you prefer.
Okay, I can answer.
And thank you very much. And consider the fact that there were only 10 animals sampled, but yeah, concerning your conclusion.
Yes, it's very short sample, and we don't know. And for goats, it's only 2 goats that I was able to modelize, so it's really not enough. And in the total assemblage, I have only 4 goats, so it's not a lot.
Okay, thank you.
Are there any other questions? I have one. So for the individuals that you were able with the like opposite trend in oxygen and carbon, where you were suggesting that they were transhuman individuals, were you able for any of those to model the seasonality of birth?
No, because as you said, the carbon is not very good. It's most of the time very flat, so we cannot modelize it. But for the one with transhuman, he was born in spring, so it's an animal which may be good for transhuman, because if you are transhuming with pregnant kiwi, it's maybe not a good thing. So there's maybe differences between sheep and goat.
Okay, thank you.
It is the only one. There are a lot of different mobility patterns, and nothing is very clear and fixed at this period.
Okay, so I guess like maybe also because it spans quite a large period of time, but that's how you you explain the different patterns, or like different. We have another question from Hannah. Hannah, do you want to ask your question in person, or should I read it out?
I can ask it. So I was curious, since you seem to be interested in identifying mobility, whether you've looked at the underlying geological variation in strontium, or other studies in the region that have generated measurements of bioavailable strontium, either for modern or archaeological samples, to help you generate a better understanding of the isoscape, particularly because mobility, covers a range of things. This can be movement around local fields in the same area of a valley, or it can be, up an altitudinal gradient or across biomes. So have you done any, able to use any other sources of information about the strontium to help you figure out what kind of movement you might be able to see isotopically?
The problem is to have a lot of modern references with strontium, because we don't know if you have a floor with one data on the rocks, then what you can find in the grass and plants, and what is then recorded in the enamels. So there is of course some isoscapes already done. The values of the range of values of Kültepe that I found in these animals are in the local values of Nakhchivan, but then it's complicated to say that they went in this place or this place, because we don't know the shift between the bedrock and the plant, when the requirement in the enamels, and also if an animal stays all of its life in one area, so maybe we can have something that looks more than the site, but if it goes only 2 weeks, 1 week in one place, 1 month, maybe the signal is shift and we cannot say where they were going.
Okay, maybe thank you so much, Adeline, for your talk. And if there are any other questions for Adeline's talk, please put them in the chat box and we can bring them up in the discussion. So we'll now move on to our second speaker. One second. Which is Dr. Rémi Berthon. So he's an associate professor of zooarchaeology, also at the Natural History Museum in Paris in France. He works in strategies of animal resource exploitation as markers of cultural and social identities in Anatolia as well as the South Caucasus, ranging from the Neolithic to the Bronze Age. And he also focuses on particular aspects of herding practices, such as, for example, interannual herd mobility. So he will talk to us about resolution of isotopic proxies to investigate herd mobilities in the Caucasian environments, modern references and application to Ovçluar Tepesi. The floor is yours, Rémi.
Okay. Do you see the presentation?
We can hear you well and we can see the presentation.
Okay, because I can't see you anymore.
Oh, okay.
All right. So first of all, I would like to acknowledge all my colleagues who contributed in these studies by collecting the samples and taking part in the analysis of the samples. Yes. So the idea is that in the Neolithic, we have pastoral systems that are characterized by a strong component of sheep and goat herding, especially in the Araxes basin, as Adeline showed, and also partly in the Kura basin along other strategies. In the Chalcolithic periods, pastoral systems are also very much characterized by sheep and goat herding. And we have also a new feature in the Chalcolithic period, at least around the Araxes basin, is that we find more pastoral campsites and settlements in the islands than in the previous periods. And I will come back to this picture of one of these seasonal campsites. So the questions we'd like to tackle is, first, if we are able to evidence vertical herd mobility, so it means a direct contact between islands and sites in the plains, from faunal assemblages in the settlements in the plains. And the second question, it's if it's possible to link this vertical herd mobility with the Chalcolithic patterns of exploitation of the mountainous areas and their mineral resources. So our research focused on Nakhchivan. So it was already presented by Adeline. And you can see on the map two particular Chalcolithic settlements that are partly contemporaries. So Uchanol and Ovçluar Tepesi, and you can see that in this territory of Nakhchivan, there are also copper ores that were exploited probably during the Chalcolithic period as well. And in green is one of the current mobility track for the herds. One of them is linking these different sites and ores areas in a northwest to southeast gradient. So one of the sites, Uchanol, so it's a campsite. So you can see from the picture, we have very light occupations with mostly post holes. It's situated 100-200 meters above sea level, so it's not an island campsite. It's probably more a stopover on different roads. It has occupations from different phases of the Chalcolithic and also from the Kura-Araxes phase. And it provided a fauna sample that is characterized by sheep and goat, with also a little bit of cattle. And as you can see on the pictures, this site is so located in the foothills. And you can see from the site Julfa, which is a gateway to the Iranian plateau. So it's likely a very strategic location for a campsite. The other Chalcolithic site here is Ovçluar Tepesi. So in opposition to Ovçluar, it's not a campsite, and at least during its second Chalcolithic phase of occupation, it is characterized by mud brick architecture with a rectangular plan, and it's lower in the plain, so it's on the Arpachai, and it's 900 meters above sea level. And as you can see, the phonospectra are also very characterized by sheep and goats, and additionally cattle. So it's also a strong pastoral signature from the phonospectrum. And also this site is a place where we discovered different copper objects and ores that are testifying the existence of an extractive metallurgy in this end of the 5th millennium BC. So before speaking about isotopic evidences from Ovçluar Tepesi, we have to come back to the methods. So the hypothesis is that vertical mobility can be evidenced from sequentially sampled stable isotope analysis in cattle or sheep and goat molar enamel. But we need a proof of concept in this environment of the South Caucasus. So we use Nakhchivan also as a laboratory to study herd mobility. And what you see here are the mobility track of different herds we studied and we documented, modern herds. So the interest of Nakhchivan is that, as you know, it's landlocked. So it's a small territory, and the herds cannot cross the borders. So it's quite easy in terms of tracks and mobilities. It has still nowadays a vivid tradition of vertical mobility with the upper alpine areas that are exploited during the summer. And so it's an interesting place to perform some modern reference datasets. So we analyzed 4 sheep so far, and with 2 mobility schemes. Some are 2-stage, so they go directly from the plain to the mountain and back, and others have stop in spring and autumn in intermediate pastures. So Adeline explained already the principles of stable analysis, isotope analysis. So I won't come back to this point. Just to say that we are going to discuss the variation and covariation of the oxygen, so delta 18O for the oxygen isotopes and delta 13C for the carbon isotopes. So the delta 13C correspond to different type of plants, because C3 and C4 plants will end up in different ratios. And also in a given environment, the delta 13C values are correlated with rainfall and temperature, and these values increase as aridity and temperature increase. So it means that delta 13C values should be positively correlated with delta 18O values. So higher delta 13C values when you have the warm season, so with higher delta 18O values. In the Caucasus, we know that the plains are more arid than the islands, and also we have C4 plants in the plains and not in the islands, and certainly not above 1,200 meters above sea level. So it means that in the South Caucasus, vertically mobile sheep should have, or animals should have, a negative correlation between the carbon and isotopes and oxygen isotopes values. So we tested some correlation between delta 13C and delta 18O. So you can see a vertically mobile sheep on the left from Nakhchivan. You can see that this correlation is negative, and the sheep that is non-mobile, this one is coming from another part of Azerbaijan, has a positive correlation. So basically, it confirms this strategy. Also, in many cases, the correlations are not significant. There are two main reasons. First, there is not enough variation in the delta 13C values to make a correlation. And the second problem is that curves of the two isotope ratios are not synchronous. So you can see here, I hope you see the arrow, but you can see here on the graph that the peak of the carbon is not in line with the lower peak of the oxygen. So it gives this kind of weird oval shape, and it doesn't provide a good correlation. So it means that we have to find another techniques than correlation. So it's probably better to try to calculate the shift between the cycles of the carbon and oxygen ratios. So it means that we have to be able to find the position of the delta 13C end members in the annual cycle of the oxygen. So on the left, you see that the peaks are well in line, so the variation are simultaneous. And so it means that the shift is around 0 or 360 degrees, that's the same. And in the case that the peaks are opposed, so you have the maximum peak opposed with the maximum peak of the oxygen. In this case, the shift will be 180 degrees. So this is a way to plot the different variations of the carbon inside the year. So if we just focus on the minimal, the position of the minimal delta 13C values, you can see that if the animal is not moving, so it has its minimum values in the cold season. That's, I would say, naturally normal. But for the sheep that are experiencing vertical mobility, you can see that their minimum carbon values occur either in the spring here or in the hot season in the summer. And we notice that the animals for whom the minimum value occurred in the spring are the ones that are going to intermediate pastures, so they are getting out earlier to some fresher or moistured grasslands. So they have their peak a bit earlier than the others that are moving later in the summer. And we can also do that with maximal position of the carbon values. That's just I give one of the two examples to save some time. Now, if we are going to the strontium isotopes to evidence geographic mobility, so geological mobility, well, just to remember you that actually the strontium that is incorporated into the body is partially reflecting the bedrock. So it's a mix of the bedrock, the groundwater that can reflect another bedrock, the drinking water, the rain, and so far so on. So it's the model is not completely understood yet. In the case of a simple vertical mobility, so from our reference modern ship from Nakhchivan, you can see that the variation of the strontium isotopes ratio is not symmetrical compared to the oxygen, and that's normal because it's not a natural variation. It's a variation that depends on the herder's decision to move, and also it depends on the length of the stay in each part. So if you stay 8 months in the plains and 4 months in the mountain, of course, your cycle will not be symmetrical. So we have to plot the different part of the cycle differently. We have also the case of multi-stage vertical mobility with stops in intermediate pastures in spring and autumn. So it provides a bit more complicated curves of variation. I would like also to stress that it's very important to define the sampling strategy for the strontium. So if we want to be able to define very finely the variation of the strontium isotopes, and finally to be able to map them to track the mobility on a map, we need to have a very fine-tuned resolution of this variation. And so I just made some tests. So we did quite extensive sampling from these modern animals, and then we reduced. We modeled with reduced sampling. So if we sample only 3 points over the crown, we completely miss the variability of this strontium variation, and we start to get good results with approximately a third samples analyzed. And well, we know that strontium analyses are quite expensive, but unfortunately, we cannot spare too much money on sampling too few. It's even worse with this one from Nakhchivan, with a very nice mobility evidence from a very sharp variation. But a top middle bottom strategy will completely fail to represent this mobility. So to conclude, just on the modern, so we have to find a way to model better the position of the carbon on the cycle to be able to analyze this vertical mobility. We can work on the timing of the mobilities with the position of the minimum and maximum strontium values. But for the moment, we did not manage to calculate the length of the stay from the variation of the strontium isotopes. And well, just to stress that we need to establish a protocol for how many numbers of samples we have to analyze, and it will depend on the length of the crown and the growth speed of the tooth. So now the herd mobilities in offshore Tepesi. So we sampled 10 sheep and goats and 2 cattle. And additionally, on the right, it's a sample from Uchanel. So you can see that in general, the carbon value is lower in the spring, summer, and higher in the winter. So it's good evidence for most of the animals kind of vertical mobility. And we have also good examples of several individuals having a diet with C4 plants. So maybe in these salty marshlands of the Araxes River in the winter. If we plot the minimal value of the carbon in the seasonal cycle, you can see that all of them, I mean, the ones we have been able to modelize, are in line with vertically mobile animals. So there's their minimum values in spring and summer. With this strategy, we are also able to show the carbon values and the season at the same time. So in horizontals, that's the season from the modelization of the oxygen curve. And here you see the delta 13C value. So here we plot only the minimal delta 13C values. And you can notice they are not so low as we could expect for animals going to alpine grasslands. For one of them, for example, it might be even too high for island meadow. So maybe it's not that summer value is very low. It's maybe because the winter value is too high, something we have to take care of. And you can see that the signature of the modern island pastures are lower. So we don't know if it's because in the Chalcolithic times they didn't go to the upper grasslands, or if it was more arid in the Chalcolithic. It's still a question we are investigating. And to finish, we also perform some strontium isotopes on this Ovçluar Tepesi material with nice variation of these ratios. And so here each line is an individual, and open circles are incomplete data because we didn't have the complete curve. And we are lucky enough to have a good amount of rodents burnt in garbage pits in Ovçluar Tepesi. So we got a nice idea of the local range from these burnt rodents. And so part of these animals were roaming around Ovçluar Tepesi, even one with very low mobility. But in other cases, we have also animals that spend 1 year of their life in another area, could be in Nakhchivan or could be somewhere else, but they ended up in Ovçluar at some point. And so you can see that it's quite a diversity of patterns, and we were expecting for the Chalcolithic periods something more homogeneous, but there are different patterns of mobility and not just ones. And we tried to plot strontium against carbon to see if there were a correlation between the carbon value and the strontium values, but it's not very the case. So even C4 signatures come from different geological areas, and there are no particular areas for summer nor winter. It's a mix of all of that. So we need to have finer resolution strategies to analyze this data. So in conclusion, Caprine played an important role in Chalcolithic subsistence strategies. And these strategies involve complex mobilities, including seasonal vertical mobility, but also really horizontal mobility. And using stabilized analysis and strontium analysis, we can reveal patterns of mobility that are compatible with an exploitation of pastures located near the copper ore deposits. But for the moment, we are not close to be able to map itineraries yet. Thank you for your attention.
Thank you so much, Rémi, for your wonderful talk. Are there any questions in the audience? Yeah, Hannah, go ahead.
Thank you. So my question, as I said in the chat, is a little bit philosophical or practical. So thank you. This data was so rich, and I think it's really useful. And what I took from your data is that in addition to not kind of fully understanding how strontium, the dynamics of that lithosphere-ecosphere interface work, that also there is this kind of potentially fundamental disconnect in some geologies between variation and strontium and the vertical mobility pattern that a lot of us are interested in seeing if we can see archaeologically. So your data about how, different kinds of sampling make the strontium data look like a different pattern is really interesting because strontium is quite expensive. And so I'm wondering how you think maybe this should guide kind of the practical consideration of where we spend our money. Is it maybe a bit of a waste of time if we don't have a good isoscape to, spend thousands and thousands of dollars or euros on finally collecting strontium data when really we should be doing bioavailability or having a larger sample size of individuals? So I wonder kind of what your take on all that is.
I see. Oh, wait, no, you're back.
Yeah, sorry, I'm back, but I was just disconnected just in the middle of your question, Anna.
Sorry, I'll try again. So to perhaps put it more succinctly, given the complexities that you're seeing in the strontium data and the kind of difficulty of connecting that to vertical mobility, I'm wondering if you kind of think that maybe this suggests that we should focus on more bioavailable strontium mapping for local regions or increasing the number of individuals rather than increasing the number of strontium samples per individual. Again, because like there's this, trade-off between how much money you spend on the incremental strontium and money for other things.
Yeah, well, good question involving money. It's a good question. Yeah, I agree that there is a financial problem in having that much samples per tooth, but it's really, I mean, we cannot spare this money because I think maybe we should analyze less teeth, but having them very well studied, each of them. Otherwise, we'll have a lot of data, but this data will be full of cases. So that's the first point. I think maybe we should analyze less tooth in the project, but having a good resolution for each of them. Otherwise, we won't be able to say anything true about these teeth. And but besides that, and you're right, I think I'm thinking about maybe decreasing the rate of analysis I'm doing on teeth and maybe focusing more on understanding what is the relation between the bioavailable strontium and what we get in the teeth before continuing. Because for the moment, I think we are at a point where we have producing a large body of data from, with strontium. And we are really in a struggle to analyze and interpret them. So we have a lot of questions, is like how the strontium is, what is reflected in the strontium we got in the enamel? Because of the enamel mineralization, how far, there is a strong dampering of the data. So how far are we from the real values that was entering into the body? So we try to work on that a bit more with our data from Nakhchivan at the moment, trying to see the offset and to analyze also. We collect dung from the animals to have really an idea of the strontiums that get into them and not plants. Yeah, but at the moment we are really in the middle of the bridge. So.
Thank you so much.
We have another question in the chat from Abu. Would you like to ask your question in person? Or I can read it out. It says, thank you, Rémi, great talk. I have a short question. Did you obtain data about the roles of donkeys and dogs in the Chalcolithic period?
No, we have almost no data, and that's because of the nature of our assemblages. We know there were dogs, that for sure, because we see gnawing marks on the bones. But the bones we are studying are coming mostly from consumption discards. And obviously they were not consuming any dog. And so we know there were dogs around, but we don't have, I mean, we have very, very few bones of the dogs because it didn't end up after their death, they didn't end up in the consumption discards. So yeah, we have dogs, but we don't know what they look like osteologically. And for donkeys, so far we have no evidence. We have very few also equid remains for the same reason. I suppose they are eating very few. They are not eating donkeys or equids. So they don't. If there were any, they don't end up in our assemblages. We have some wild equids, very few, but I'm not sure we have evidence for. I'm pretty sure we have no evidence for donkeys in the Chalcolithic South Caucasus so far, and not from the data I know well.
Okay, thank you so much, Rémi. Okay, he replied. Got it. Thank you so much. I guess we can move on to the next speaker.
So can I introduce you?
Yeah, you can.
So it's our great pleasure to have our committee member, Gwendoline Maurer. She's a PhD student and her research focus on explore the animal-based subsistence of Kura-Araxes horizons through the isotopes. She was working on early Bronze Age Kura-Araxes animal bone assemblages in Levant and Caucasus, and she utilized multiple techniques such as zooarchaeology, zooms, in order to understand the mobility and the diet of animals. And so, Gwen, the stage is yours.
Thank you, Magda. Wait, let me quickly share the right screen. Okay, here we go. Oops. Can you see my presentation?
Yes.
Okay. So yeah, I'm going to talk to you about part of my PhD project, which is investigating Kura-Araxes pastoral practices in the Caucasus and the Levant, using zooarchaeology, stable isotope analysis, and zooms. So first I want to talk about the Kura-Araxes culture, which is an archaeological complex that my presentation and research deals with. So the Kura-Araxes culture is an early Bronze Age archaeological complex that emerged out of late Chalcolithic traditions in the South Caucasus and Eastern Anatolia. And traditionally, the South Caucasus and Eastern Anatolia are considered the so-called core areas of this phenomenon. What is interesting about the Kura-Araxes, or why people have been intrigued about the Kura-Araxes phenomenon, is because towards the 4th millennium BC, beginning of the 3rd millennium BC, it spreads to other areas such as northwestern Iran, the upper Euphrates Valley, but also the Amuk Plain, modern-day Syria, and as far south as the southern Levant, where it is locally known as Khirbet Kerak. The Kura-Araxes have always been described as small groups or village societies lacking any kind of social stratification and being egalitarian in nature. What I always found interesting is that Kura-Araxes is surrounded by very different, sometimes more or less contemporaneous phenomenon, such as the Uruk phenomenon or Maikop, which are known for their social hierarchy in state systems and expansionism. It's also interesting to note that in some areas, as Uruk influence decreases or collapses, Kura-Araxes phenomenon spreads into those areas, such as in Iran or the upper Euphrates Valley. In the southern Levant, the Kura-Araxes phenomenon shows up in the early Bronze Age III, and this kind of coincides with the disintegration of so-called urban systems. Then overall, Kura-Araxes have like sort of specific material culture associated with them, such as distinct red and black burnished ware, distinct zoomorphic figurines, portable hearths, as well as specific architecture and burial traditions. So over time, these kind of material culture and attributes have become tangled up with culture and have become so-called cultural markers to identify the presence or spread of Kura-Araxes phenomenon in the different areas that I described. So that's kind of important to note. So what are some of the key questions surrounding Kura-Araxes? So we're trying to understand if this is the movement of people or the spread of adoption of new ways of life. And if they're moving or this phenomenon, whatever it is spreading, why? And one of the reasons we don't really understand this very well is because there's kind of a lack of clear baseline understanding of Kura-Araxes socioeconomic practices from the Caucasus, but also outside areas such as the Levant. So one of these aspects that are very poorly understood are Kura-Araxes animal economies. So we don't really understand how Kura-Araxes phenomenon or people associated with this phenomenon used animals or how they used the landscape. So there are some archaeological studies associated with Kura-Araxes sites, but there are around 15, and I guess in the South Caucasus itself, there are over 700 sites, so comparatively few. So when you look at the literature, Kura-Araxes are described with different terms, such as transhuman herders, mobile pastoralists, agro-pastoralists, nomadic pastoralists, or sedentary farmers. Obviously, all of those terms have different socioeconomic consequences. And they are mainly based not on zooarchaeological or isotopic evidence, but on other evidence, such as, for example, the environmental layouts or the location of many of those sites in the Caucasus, which is obviously a mountainous region. So the idea that they must have been moving to different altitudes and there must have been some sort of movement or transhuman behavior. Also things like the combination of sites being located in the plains as well as in high altitudes. And some have suggested that some sites have very thin cultural deposits, and therefore it's kind of inferred that they must have been moving a lot or have some sort of nomadic nature. So my research questions thereby focus on clarify some of the basic assumptions about Kura-Araxes pastoral systems, and thereby characterize pastoral systems as Kura-Araxes sites in the Levant, but also in the South Caucasus. So I'm trying to understand the extent and level of mobility of the herds, hence maybe people. So the distances covered, and if there were any transhuman systems in place or not. Then understanding the geographic and seasonal movement of the herds, and if so, if these were locally carried out or over longer distances, and how they organized their animal economy. So the seasonality, seasons of birth, seasonality of diet, but also the range of species exploited and general management practices such as management goals. So I focused on 4 sites, Tepesi and Tepesi, which are both located in the southern Levant, and then Mukhtar and Zooarchaeology, which are located in the Caucasus. And so I'm quickly going to introduce the site. So Tepesi, as I said, is located in the southern Levant, next to the Sea of Galilee. And it's important to note about the site that Kura-Araxes phenomenon shows up in the early Bronze Age 3 and is contemporaneous at the site with local Levantine traditions. Then Tepesi, very close, located very closely to Tepesi, like around 10 kilometers south in the central Jordan Valley. Again, it's a site where Kura-Araxes traditions are found alongside or contemporaneously with local EB3 traditions. Then Köhne, which has late Chalcolithic and Kura-Araxes layers. It's located in the lowland and plains of the Karabakh. You can see the landscape kind of here on the picture. And then Mukhtar 1, which, like the other sites that were discussed before, is located in the Autonomous Republic of Nakhchivan. It's located at 800 meters above sea level, so a kind of different environment than the others. Yeah, and I don't think I need to explain too much about the environment as the others already did that. But basically, it's very much surrounded by mountainous landscape. And here you can see kind of environment and vegetation around Nakhchivan. So this picture was taken in late winter at the end of February. So you can kind of see the scant vegetation and shrubland and how it's punctured by different highlands, and you can see the Zangezur Mountains in the distance in Armenia. So I went to all these places to collect my sample. So been working on, first I went to Tabadere in 2016, and then been working on the material of Taliakush since 2018. And just before Corona, I had the chance to go to Nakhchivan to collect some samples from Makhta. And as well as last summer, I was working at Tepe to look at the zoological assemblage. Sorry, I'm losing my voice. So now to some of the zooarchaeological results. So you can see it's mainly dominated by domestic ruminants, sheep, goats, and cattle. Hunting is attested in form of deer species and gazelle and possibly wild boar. However, these seem to have not played a significant role in any of the site's subsistence strategies, except possibly at Taliakush. So considering the importance of domestic ruminants in the assemblage presented here, so of caprines and cattle, we may conclude that Kura-Araxes communities focused on pastoralism. However, the prominence of suets, especially at Taliakush, if these represent domestic pigs, could point to a mixed farming strategy rather than a pastoralist system. Overall, the fauna spectra kind of suggests that these Kura-Araxes communities were highly specialized, or maybe not highly specialized, but some way specialized in domestic, medium, and large-sized ruminant herding, and that there is somewhat diversity in the species spectra between the different sites. So now looking at some of the management goals, or comparing some of the management goals between different Kura-Araxes sites. So we're just going to focus on caprine, so sheep and goat. The ones with an icon are where all have been identified as sheep, and the ones that don't have an icon could be either sheep or goat, so they've just been put together. So the age of slaughtering, or the time when you kill animals or these caprines, can be a good indicator of the community's management goals and practices, but also in some way maybe mobility of the herd. So as you can see, it seems that management goals vary greatly between those sites. Tabadere and Makhta, one show a particular focus on maybe keeping very old animals, which I guess to some way can be linked maybe to exploitation of wool. Ovçluar, even though located very close to Makhta, shows a very drastically different pattern and a high focus on killing very young and juvenile animals. Kültepe, located in the south of Georgia, shows a focus on juveniles and prime adults, maybe for the exploitation of meat. So these sites virtually show no focus on keeping animals to an older age. And Tepe is showing sort of similar pattern with limited focus on old adults, whereas Köhne, located in Iran, is kind of showing a mixed strategy. So again, it's kind of pointing to the diversity of strategies employed by these communities. So I used some zooms, but only as a pre-step for isotope analysis to differentiate between, reliably differentiate between sheep and goat. Sometimes the morphological criteria are not that clear. So just like for those who don't know the process, I just quickly outlined it here. So the results, so from Makhta, we analyzed 20 caprine mandibles, of which 19 turned out to be sheep and 1 a goat, and at Tabadere 25 and 2 turned out to be goats, and 23 of them didn't work because the preservation wasn't good enough. So now, I guess this was already explained by the other 2 presenters before. But I'm hoping to use some stable isotope analysis to answer some of my research questions. So I'm mainly focusing on oxygen and carbon. And I guess it's important to understand, but it was mentioned before, that animals incorporate, for example, oxygen isotope ratios through the oxygen they inhale, but mainly through the water source they consume, but also the water they consume within leaves. And for carbon, it's mainly affected by the consumption of vegetation that the animal consumes. So whether it's consuming C3 or C4 plants. So how is this? So how can we use this to answer any questions? So as you can see here in the tooth diagram, so as the tooth forms from the root to the crown, the enamel mineralizes at different times depending on the location on the tooth crown. And once it mineralizes, isotopic signals are locked in time. So then ideally we can go back and kind of in a systematic way sample along the tooth crown and try to reconstruct, depending on the tooth, 1 or 2 annual cycles in the animal's life. So just quickly focusing on oxygen isotopes. So these obviously vary naturally in the environment, depending on different factors. So for example, altitude has an effect on oxygen isotope ratios. So the higher you go up in altitude or mountainous environments, the lower the ratios. Water sources are also affected. For example, water sources that are in higher elevations or fed by snowmelt will have lower oxygen isotope values than water sources, for example, located in the plains. And then, as previously mentioned, seasonality, so climate has an effect with higher values to be accepted in summer, so like dry and warm climates, and lower in winter and wet climates. So you can see how this can be used to reconstruct or to understand transhuman systems or mobility in general. And it can also be used to calculate the season of birth. And then very quickly, carbon isotopes, mainly affected by if the animal is consuming C4 or C3 plants. So it's important to understand, I guess, in our case, that in highlands or mountainous environments, we would expect mainly C3 plants compared to at lower altitudes. So now I'm going to quickly show my data, and I think I have to quickly change my screen for this. Can you see it?
Yes.
Let me access this. So those are my results from the isotopic analysis from Magda 1, mainly on sheep and 1 goat, somewhere in between. To be honest, I have not spent enough time yet to completely understand all the patterns. But overall, it reminds me very much of the patterns that Rémi showed before of transhuman behavior in Nakhchivan, where the oxygen and carbon is opposed. And also what Adeline was showing from Kültepe of sheep that were also moving between different altitudes in different seasons. And just as a comparison, can you see the other?
Yes.
Okay, so just as a comparison from Zooarchaeology, you can see that it's in sync, which might suggest that they are maybe just maybe not moving. Well, it also reminds me again of what Rémi was showing of the sheep compared that were staying at the same altitude all year long. So yeah, if you have any comments on my patterns, I'll be very happy to hear them. Let me quickly go back. So yeah, so I was basically thinking that the ones from Magda 1 were maybe accessing the highlands or pastures here in summer versus the ones in Zooarchaeology were using the plain landscape around for their animals. Yeah, so again, you can see that kind of more diverse strategy than previously thought. I lost access to my screen somehow. Yeah, so that's it. Thank you very much. If you have any questions, let me know. If there are no questions, I guess we can move on to the next speaker.
I have one question. Not a question, but a remark, because there's something very different between our values with Rémi on Chalcolithic and me on Neolithic. About the C4, we are not most of our animals are not going in C4, and for you it's completely different. So there's maybe something different in the pattern of occupation of places. I don't know if there is a lot of C4 plants next to Wooster, but it's very impressive. You are only in C4 plants, and it's completely different. Even in Georgia, for same period, for early Bronze Age, I don't have a lot of C4 plants.
Okay, yeah, that's interesting. I'm not too sure about the vegetation yet. I'm still looking into that. So I'm not able to answer your question. But thank you for your comment. That's really interesting. Rémi?
Sorry. Yeah, I noticed the same, and especially in Tepe, you have seasonal variation with some access to C4 at some point in the summer. But in Marta it's impressive. But Marta is really in this. Marta is more in the alluvial plain of Charur, so it's in the middle of the alluvions, but it's buried under alluvions. But around these alluvions, so in the slightly higher place where there is no alluvion, it's really this very salty steppe area, like in Bugduz and so on. And so it's really, I could not test the values yet, but we interviewed some herders that are from this lower land place. And some of them, they leave their animals in winter outside, and they eat mostly spiky stuff that are halophytes, so very C4 plants. And so it's not surprising to have a lot of C4 plants just on the shore of the Araxes, because it's very salty over there and very steppic. So C4 plants resist better than C3 plants in this arid and salty environments.
Okay, that's very interesting to know, because I was wondering about that, if it's possible in winter. Yeah, okay. Thank you so much for your comment. Are there any other questions? I guess no. Okay, so I will go on to introduce our last speaker, which is Dr. Siavash Samei. He's a visiting assistant professor of anthropology at the Wooster College. He's an environmental archaeologist. He studies the interplay between environmental change and foraging herding economies of non-state societies in the highlands of West and South Asia, using archaeological, isotopic, and ethnographic methods. He's currently a co-director of the Tübingen Armenian-American Paleolithic Project in Armenia and the pastoralist of the Aravalli Range Ethnoarchaeology Project in Rajasthan, India. His first book project is a zooarchaeological and behavioral ecological reconstruction of early Bronze Age pastorate landscapes in the Near East and Southern Caucasus highlands. Also in fall 2023, he will join Central College as an assistant professor of anthropology. Thank you for joining us, Siavash. The floor is yours.
Thank you. Good morning, everyone, or good evening, depending on where you are at the moment. I'm just gonna share my screen. Well, actually, let me do this rather. If I go here. Okay. Okay. Can you all see my screen, and do you see my notes or not?
I don't see your notes, and I can see your screen well and can hear you well.
Wow, excellent. Thank you. Well, good afternoon and good evening wherever you are. Thank you all for being here, and thank you to Network for organizing this and for inviting me. For me, I think the opportunity to talk at this wonderful panel was sort of a way of actually getting started in synthesizing my many years of zooarchaeological work at the Kura-Araxes out of Köhne, specifically using faunal remains to analyze and explore inter-community interactions. That this synthesis is really sort of my way of beginning to put my findings from 3 different publications, as well as some additional and ongoing spatial analyses, into conversation with one another using a unified theoretical framework. Unfortunately, I'm not going to be able to really explore the theoretical grounds for this talk or get as deep into the analysis as I would like to, just because it's been a busy academic year. But I still want to give you a sense of the kind of approach itself. I also will not get into the methodological and technical weeds of the various analyses I'm going to talk about here. I'm going to refer you to the papers themselves for that kind of information. Instead, what I want to do is just incorporate some of these already published analyses from these papers together to formulate begin to formulate a more unified and complete story about intercommunity relationships and life at Köhne. Many of you know Köhne or KSH, but in case you do not, just as a quick intro, KSH is an early Bronze Age site in the Kura-Araxes cultural tradition, and Gwen already did a wonderful job of making my life easier and presenting a very good introduction about the Kura-Araxes cultural tradition itself. The site is about 15 hectares in area at about 1,910 meters above sea level in northwestern Iran, not too far from some of the sites that Rémi and Gwen others have talked about or work in the northwestern Iran and the southern Caucasus region. It has 3 areas, as you see on the slide, but our excavations and faunal analyses have been concentrated in the fortified citadel of the site, where we have identified 5 architectural phases that fall into 2 ceramic horizons. What I'm going to talk about here today mostly comes from the upper horizon that corresponds to phases 4 and 5, dating to between 2900 to 2500 BCE. The KSH citadel in the upper horizon, as you see, is laid out in a spoken wheel pattern in which multiple alleyways lead to and from a central plaza that divide the settlement, the densely occupied settlement, into multiple neighborhoods. Excavations in 3 of these neighborhoods, the eastern, western, and central neighborhoods, have revealed architectural remains and objects and faunal remains from a host of contexts, all of which are direct evidence of manufacturing workshops and associated domestic spaces, store spaces, possible administrative functions, and waste dumps. These workshops engage in a mix of productive activities, including textile production, pottery manufacturing, production of metal objects, bead manufacturing, hornworking, and making of other small and fine objects. We don't actually know the entirety of the range of material that was produced and manufactured at KSH, in no small part because our findings have been mostly limited to the production processes themselves, and we have yet to find a large number of finished goods, suggesting that KSH may have been a regional manufacturing and industrial center that exported its various products. Faunal remains are the second most common class of archaeological material at KSH after pottery, and we can say the same thing about most Kura-Araxes sites and the abundance of faunal remains in them. And at KSH, they are present in most aspects of daily life and production activities. What makes faunal remains unique, including across the KA tradition, but really everywhere, is that they represent the materiality of a large body of living non-human animals and their interactions with their human counterparts, how they were incorporated into a multitude of daily tasks, and how they gave meaning to our cultural practices and daily routines. Animals have been, are, and were sources of wealth, companionship, and insurance. They were providers of food and sustenance. They were providers of labor and transport. They were our technologies and also sources of raw material for crafting technology. They were providers of warmth and protection. They were mediums of exchange and mediums of community building and cultural expression. So in many ways, they are at the center of everything that we do, we make, and we believe in. So as a material constant of such potential, I think fossil remains have invaluable insight to impart in our reconstruction of routines, daily tasks, and the hubbub of community-wide interactions and relationships, including at Köhne Şehir. We can use final analyses to trace the functional history of animals from the living whole to their fragmentary remnants. Tracing the life cycle and use of materials is methodologically and epistemologically well established, from Schiffer's early models in the 1970s to the various implementations of the concept of chaîne opératoire, to the understanding the social life of objects through the lens of object agency, or Ian Hodder's entanglement theory, the entanglement between things and things, things and humans, and of course humans and humans. As I said, I will refrain from an in-depth theoretical discussion here because I'm not quite prepared for that, but suffice here to say that tracing the life cycle of faunal remains to understand inter-communal and community relationships is a well-established archaeological practice that can be implemented in different ways, and I want to explore one way of implementing that here today. So to begin understanding how both wild and domestic animals were circulated and shaped community relationships at Köhne Şehir, it is first important to understand where these domestic animals or these herd animals originate from. And I begin with both domestic and wild animals. I will begin with domestic animals and herd animals, asking who kept them and or acquired them and how those activities were organized. My studies have so far shown that animal herds at Köhne Şehir consisted of mixed herds, focusing on sheep, goat, and secondarily on cattle, in many ways reflecting, I think, a growing dominant pattern across the board, despite all the important diversities that exist that Gwen referred to in her wonderful presentation. The survivorship data, as well as the mortality data that are not shown here, show that these herd animals were not intensively exploited for any one product or service, but they were exploited more generally for meat and a range of the secondary products and services, including dairy, wool, labor, and most likely dung. The use of cattle for labor, among other products, possibly to pull two-wheeled carts or plows, is confirmed independently by the presence of osteopathological specimens, one of which you see here on the screen. Our isotopic analyses that just came out a few months ago unsequentially sampled teeth show no significant evidence of specialized nomadism. It is clear that most cattle and caprines were managed locally, and that with two exceptions, which I'll talk about in a moment, foddering during the dry months was complemented with some degree of limited vertical transhumance in the immediate vicinity of the site for both groups. Although cattle were most likely kept closer to the settlement where they had access to more permanent sources of water, while caprines explored somewhat higher elevations. The two exceptions I'm talking about, you can see them on both of these graphs, are one cattle individual, TB16, and one caprine, TC54, which were most likely raised elsewhere and brought to Köhne Şehir as adults. So to wrap up this part of the talk, just to summarize some of these observations, I would argue that the extensive nature of animal management practices at Köhne Şehir represents what one could call a risk-averse animal husbandry strategy, typical of village-based subsistence economies that satisfy the immediate and possibly medium and long-term subsistence needs of its residents. And households. Although few animals were introduced to the community by some possibly migratory elements or more mobile pastoralist communities, it is quite clear that most of the animals were raised and kept locally at Köhne Şehir by its residents, some of whom, possibly a few individuals, would take some subsection of the animal, of the herds to higher or lower elevations for various lengths of time. Please do forgive my really childish graphics here. These demonic arrows will show up several more times. So I apologize for those. So I think having established some sense of where the domestic animals originate from, that they are local and raised more or less in a sedentary manner, thinking of sedentism and non-sedentism as a spectrum of mobilities. We can now turn to how these animals could be incorporated into community building at the site through exchange and through interpersonal contact. How are these faunal remains, in other words, being circulated across the site? Now, talking about residents of the matter, talking about households is a difficult, I think, an elusive unit archaeologically, certainly in prehistory and protohistoric periods, because one discrete domestic space, for example, does not equal one household, right? But the site, so I'm not going to talk about it in terms of households or residents, but the site layout itself presents neighborhoods as a natural unit of spatial analysis, as a representative of some geographically discrete parts or parts of the community. And I use that to do some of this spatial analysis. Now, these existing analyses do not show any, I would call meaningful differences in taxonomic abundance or in body part representation between the neighborhoods. I'm gonna start, and I've already started looking at these spatial distributions using other analyses in other ways to see if one can detect any meaningful patterns. But I would argue that, even this uniformity at this broad neighborhood level scale is meaningful. We often try to interpret or look for evidence of food and meat circulation in the context of spatial evidence for spatialization, right? So food distribution mechanisms in urban environments being a great example, where through indirect provisioning, food goes from one place to another, and then it leaves differential archaeological signatures in different contexts and different parts of the site. But the subsistence-based economies of the type I described earlier is typical of communities where residency is usually determined through ties of kinship. And as such, uniformity in both taxonomic abundance and body part representation is not evidence for the absence of a need for movement of animal products, specifically meat, but rather may represent significant degrees of exchange and circulation of meat throughout the settlement. And I turn my attention to the wild game at Köhne Şehir. Who's hunting them? What are they being hunted for? And how are they incorporated into the community? Sorry, I made a graphic mistake. That's a graphics mistake. That's okay. Wild game make up only 10% of all faunal remains at Köhne Şehir, but they represent a great taxonomic diversity. Some of these animals are represented by only one or two single bones, others by a few specimens, mostly from extremities with cut marks. Some others, especially red deer, have more complete body part representations. Now, in the upper horizon, the central neighborhood has the highest density of wild game, with meaningful taxonomic diversity in both ungulates and carnivores. The isolated bones of some of these dangerous animals, such as bear or eagle, may represent curious finds or amulets of personal significance, though they do not have visible anthropogenic modifications. Perhaps opportunistically collected or isolated remnants of hunted animals. The body part representation and cut mark treatments of other animals suggest more active hunting for their meat, especially with the equids, either onager or a medium-sized small domestic equid like a donkey, but also for their valuable fur, such as with badger, marten, wolf, and fox, which is in line with the craft economy of the settlement. These remains are heavily concentrated in Trench 12I8, particularly in the open space of the plaza. The centrality of the plaza would serve as an ideal space for a marketplace in which hunters from elsewhere or as members of the same community would showcase and trade or distribute their hunts and quote-unquote exotica. There's also some evidence of hide and horn working in the adjacent central neighborhood, and the animals whose fur were valuable were butchered and skinned right next to the plaza by those artisans specializing in working with animal skin and fur. And last but not least, looking at just deer as one example of differential circulation pathways at the site. So deer are cervids, and these are mostly large deer, so red deer, are most densely concentrated in in all three neighborhoods, but most of the postcrania is concentrated in the central neighborhood. These include cranial fragments with postcrania and crania, not including antler. So this also includes cranial fragments with pedicles, which suggests that in addition to opportunistic collection of shed antler, they were also actively hunting deer that still had their antlers intact. The antlers are primarily concentrated in the eastern neighborhood. Some are also found in the central neighborhood. The deer specimens, namely the antler, make up more than 50% of the bones in several buildings and spaces in the eastern neighborhood. And the antler is particularly abundant in all but one structure, which is S401 and its two rooms, S411 and S412. Among the antler, the tools and the non-modified remains, or the tool blanks, are distributed differently and differentially across space. And there's some differences in the size of the remains that are not the tools. So the larger the largest specimens are in S103, and the smallest ones are in S101, and the intermediate ones are in S202, S208, and S404. It is notable that S101 has a tremendous amount of ash in it, whereas where we have the smallest fragments, and S103, where we have the largest fragments, we don't have much of anything else in that space except these large antler fragments. So what it seems to be the case is that I would argue that structure S103, which is also the same more or less as structure 402, they were just named differently in different seasons and different trenches, but they're part of the same space, represent raw material storage spaces, specifically antler storage spaces. Whereas structure S202 and S204 and a couple of the other ones in the eastern neighborhood reflect the craft production units, where we have also other tools. We have a few beads and bead fragments, bead blanks, textile manufacturing tools, and pyrotechnological installations associated with craft manufacturing. And S101 is most likely the dumpster. And you can just see how the raw material would go from the storage spaces to the workshops and then back, and then be jettisoned and dumped in the waste disposal areas. It's also noteworthy that the raw material storage spaces and the dumpsters are all in the immediate vicinity of each of these workshops. They're not too far from where the workshops, where the manufacturing activities themselves are taking place, which suggests that despite the interconnectedness in the community, there's a degree of autonomy, independence in the functionality and the stages of manufacturing in each workshop in these various neighborhoods. And I just gave sort of antler as one example. And you see, that horn working using cattle horn, the horn of wild goat and domestic sheep, for example, is taking place elsewhere. You see that antler is used, I argue in one of the papers that antler is used as the predominant raw material for making tools in the eastern neighborhood, but in fact, it's not at all the predominant tool in the other neighborhoods, which suggests some degree of preference for raw materials between different workshops, between different groups that are working on this material. I think ultimately what I'm trying to get toward, and I would very much appreciate some feedback and questions and your thoughts, is that the community at Köhne Shahar is organized around a multitude of different types of relationships. And there's lack of uniformity in how material is moving, how the movement of the material is organized, and who is responsible for the movement of the material. Thank you so much for your time.
Thank you so much, Siavash. That was really great. We have one comment in the chat and one question. Nushik, do you want me to read out your question, or do you want to ask it yourself? I can read it out. So is the book... Okay.
Hi, everybody. Hi, Siavash. Thank you. That was a great talk. For the pathology you presented here in your presentation, Please, could you tell me if this is a result of the food system, or like deficiency in the food system, or something metabolic or something else? Is there any more deep study?
Yeah, I would like to be very careful in not mischaracterizing what I know and what I don't know. And so my knowledge of the degree to which this could be representing some sort of metabolic or genetic condition is next to none. What I am going by is based on the existing literature that looks at some of these abnormal, atypical bone growth and bone development as a sign of labor-related stress, predominantly because they're found on those parts of the body that are weight-bearing. So they're typically found on phalanges, they're typically found on the hooves, maybe found like on camels, for example, or animals that carry tremendous amount of weight for long periods of time. They're found on the thoracic vertebra where weight is usually sort of sitting. So in that sense, the distribution suggests most likely these are related to either advanced age and or to stress related to extraneous labor.
Okay, I see. Thank you very much.
Are there any other questions? Rémi.
Thank you, Siavash. Was very, very interesting. Well, this site is amazing. I mean, it's really a incredible site, and so you showed it's really an amazing center of production, and I think it's quite a unique case in my knowledge of the Kura-Araxes settlements. And also the other puzzling thing is that this site is in a corner of the region that we know very. I mean, we have very few information, but this corner close to the Ararat. So my question is, such a center of production will need a network. And do you have any idea what will be the network of this site, considering its geographical position?
I would say no. I know that I think long distance nomadism is oftentimes evoked as a way of explaining some of these relationships and regional networks. And in my own work, I have hopefully a paper coming out in a volume contribution maybe in the next year or two to talk about the lack of evidence for specialized nomadism in the Kura-Araxes, and the fact that I think this is more of a product of some of the terminological issues that Gwen talked about in her previous talk, as well as I think projection of some modern contemporary realities onto the past. So my answer is no, I don't know. But one of the challenges I think we have, and perhaps Köhne is not the only case, is that it is safe to say that obviously people in the Kura-Araxes, including the Köhne, are in contact with one another. They know that they exist. They probably know about the Uruk systems and the collapse of those colonies, at least in Mesopotamia. Like, these are knowledgeable people, and yet when it comes to direct actual evidence, honest to God evidence of some of these interactions, you don't see them. It's difficult. They are very elusive. I mean, for example, we have broken pieces of pottery at Köhne with bitumen residue on them, and we know that the bitumen, at least based on current understanding of surveys, the closest source of bitumen is in the Iraqi Kurdistan, maybe parts of eastern Turkey. So that could maybe be a sign of long distance connections. If the equids that we have are in fact donkeys, then they could be a sign of animals used for some of these. For maintaining and realizing some of these trade or exchange routes. We only have 4 or 5 fragments in equids, and they're not even good enough to be measured. They're not measurable, really. So my answer is no. I don't know what that would look like, but I agree with you that sort of network should exist. At Kültepe, I would argue that there is strong evidence of some. I'm saying this is a medium confidence statement of specialized wool production. Based on sheep, and yet, well, who's consuming this sheep, right? I mean, surely they themselves are not consuming all this wool. A very obvious, I think, culprit or suspect would be southern Mesopotamia, because there is historical accounts that the wool of the Zagros Mountains is the high quality wool. right? That's sort of coveted, and yet we have again no direct evidence that in fact that trade would have existed between Kültepe and Mesopotamia. So my short answer is no. But I'm curious to know if you and other people might think.
Thank you.
Any other questions or comments?
Yeah, actually, I would like to ask a second one.
Yeah, go ahead. Yeah, sure.
Thank you. Yeah, me again, Siavash.
No, I like it.
So the citadel seems to be, yeah, very peculiar compared to anything we know. But I noticed on the pictures there is a lower tone. So were there any excavation in the lower tone?
Yeah, so yes, there's a lower town, and there's one trench, one excavation. The lower town is under heavy alfalfa cultivation, and when we excavate, I think the farm is in use. And then we did intend to go back, but life happened such a way that we could not go back. However, between where the edge of the farm is and where the wall collapses, there is some unfarmed, uncultivated space, and so we opened one trench there. A season that I was not there, and we only did sort of one architectural phase of excavation, so we did not go too deep. We don't know how deep the outer town is, but the one trench was another structure similar to the ones we see inside, with similar range of material. Most of them heavy or I think hammerstone type material that's probably used for crushing ore or other crushing, breaking other things. Similar pyrotechnological installations, the same kind of ashy deposits and small crucibles and beads that we see on the inside as well. And so the evidence suggests the same kind of, that one trench, the same kind of activity was taking place outside the wall as inside the wall. But one question remains is what is the chronological relationship between the outer town and the citadel? The pottery analysis suggests that it could be contemporaneous with phases 4 and 5, so the upper horizon, but we need carbon dating to be sure. So it remains unknown exactly the chronological relationship.
Very exciting. Thank you.
Any other questions or comments? I have a quick question. Could you maybe quickly elaborate on the isotope results? So you were saying that essentially it showed that there was not any vertical mobility, and they were basically just using the landscape close to Köhne.
Yeah, so the oxygen isotopes are quite divergent, which is understandable. Different physiology, different metabolism, different I think water consumption practices. Or habits rather. Goats at least are not necessarily obligate drinkers. Cattle are obligate drinkers, and they drink quite a large amount of water. And so it's natural that they are reliant on more reliable permanent sources of water, rivers, springs, two of which are in the immediate vicinity of the site, than let's say sheep and goat, particularly goats. Whereas sheep and goat take most of their water from the food that they ingest, hence the differences in oxygen isotope values. One cattle individual, however, had a particularly low delta 18 oxygen 18 value, which it's only one. It's a good sample. I don't think it's contamination. It could be, but I don't think it is. The lab doesn't think it is, and so I think it most likely comes from somewhere in the same elevation as the Araxes River, even a more permanent body of water with more negative, that's more depleted. In heavier isotopes, and I think the Araxes River would be the best, I think, guess. The Caprines, the oxygen isotope value suggests, again, ingestion of vegetation, water intake through ingestion of vegetation and pasture. But what's interesting is that the carbon value for both sets is quite similar. It's both quite similar. There's no statistically significant differences in the mean carbon 13 values, and for that matter, there is not much distance between isotopic maxima and minima among the carbons. I think the average difference ranges about maybe 1 to 2 per mil, give or take. I think plus half permanent maybe, which can be counted, I think, by the natural variability that one can expect for one locality in a temperate region, based on some of the research from the Levant, but extrapolating that and talking about the northwestern Iran as well. And so that can account for that. Now that I think a tight range in isotopic variability within each individual tooth could also be explained by, I think, definitely some of the, I think, time averaging consequences of the fact that enamel deposition is far more complex than our sequential sampling allows, and I'm certainly happy to accept that as one additional explanation. I don't think we would explain everything, but because I would still, if it was just that, I would still expect to see some what we'll call seasonal variability, and it's really not there. Another one could be foddering, and the foddering is definitely a reason. And the other thing I would say is that the means delta C13 values are higher than the mean and the median for the sampling for the environmental baseline, that small environmental baseline that I developed and defined for the region, based on both vegetation sampling, modern vegetation sampling, as well as collagen analysis on wild caprines and lagomorphs from the site. And that is in part, I think, just foddering. Foddering is a reason, because if they are collecting summertime fodder and it's drying up, then in the winter they will get summertime signals. It could be C4 vegetation. I don't think there is not much modern evidence of modern C4 vegetation in the vicinity of the site. And so I'm not quite sure about that. And ultimately, the range of mobility can be detected even with that tight range of mean median values for carbon. I think accounts for about 8 to 1,000 meters of change in elevation, which I think, because of the altitudinal gradient around the site is very steep, it can be accounted for. I mean, you will reach 800 to 1,000 meters. I mean, you will go up or down, straight up, within a one-day radius, within a 20-25 kilometer radius of the site. So I don't think, even though 800 to 1,000 meters elevation gain or loss is significant, given the altitudinal climb of the region. In fact, it can be achieved quite quickly. As far in terms of the distance traveled.
Okay, thank you so much for your elaborate answer. I think we have maybe time for one final question or comment, if there is any, since our time is sort of up. Otherwise, I will conclude. Okay. Let me quickly share our, oops, no, not this. Thank you so much, Hannah, for joining. Okay, so we'll come. So yeah, thank you so much for everyone for joining, and especially to our speakers. Thank you for taking the time to present your work and doing this in your free time, and we really appreciate it. And also for the audience for staying and for joining, thank you so much. So if you would, if there's anyone in the audience who would like to give a talk in any of our upcoming seminar series, or has an idea for the network, or who wants to organize their own seminar or give a talk in general, please contact us. You can find us on Twitter, or you can email us. You can see our email there. Also, if you have any suggestions or comments for the network, we're very, very happy to hear them. And yeah, thank you for being part of our growing and developing network. And I hope to see you in the future.
Thank you.